Introduction to OCRs. All electric systems are susceptible to outages resulting from faults caused by trees, wind, animals, human error, and insulation failure. Faults are removed from the system by fuses, circuit breakers, or circuit reclosers. This video focuses on the application and operation of the automatic oil circuit recloser, commonly known as the recloser or OCR. Overcurrent protection of electrical circuits is needed to protect conductors and equipment from thermal damage caused by excessive current flow, which can be caused by overload or by system short circuits or faults. Overloads are minimized by proper design and operating practices. System short circuit conditions are handled by automatic overcurrent protective devices. Faults can be classified into two general categories: temporary and permanent. Temporary or non-persistent faults are those which will cease if the line is quickly de-energized. Permanent or persistent faults de-energize part of the system and require repair or replacement before re-energization can take place. Studies show that 80 to 90% of faults that occur on an overhead rural distribution system are non-persistent or temporary. General information. An automatic circuit recloser is a self-controlled protective device designed to interrupt and reclose automatically in an alternating current circuit. This is accomplished through a predetermined sequence of opening and reclosing, followed by the unit resetting itself or tripping into lockout mode. Purpose: reclosers are installed to provide maximum continuity of service to distribution loads simply and economically. This is done by removing a permanently faulted circuit from the system or by instantly clearing and reclosing a circuit subjected to a temporary fault. Unlike fuse links, which interrupt either temporary or permanent faults indiscriminately, reclosers are able to distinguish between the two types of faults. They give temporary faults repeated chances to clear or to be cleared by a subordinate protective device. If the fault is not cleared, the recloser recognizes the fault as permanent and operates to lockout. Application: automatic circuit reclosers are used in distribution substations and on branch feeders to protect distribution circuits and to switch them. Proper application of OCRs requires a study of the load and the short circuit characteristics of both the protecting and the protected equipment. This includes high voltage fuses or other protection devices in the supply to a substation transformer bank, a circuit breaker or reclosers at the distribution voltage supplying the feeder at the substation, various line reclosers, sectionalizers, line fuses, the wire arc burn down characteristics at the fault location, ground resistance, etc. The details of developing a sectionalizing study are beyond the scope of this presentation. The line reclosers must be designed to carry full load current, respond to the calculated minimum fault current at the end of the line section it protects, and be able to interrupt the maximum fault current at the recloser location. This information is found on the recloser nameplate. In summary, the objective of incorporating OCRs into distribution system sectionalizing are: to attain the minimum practical minute outage per consumer per year, to attain the minimum practical expense of service restoration after outages which are caused by primary line faults, to minimize damage to primary lines and apparatus during faults, to minimize the probability of a hazardous voltage at ground level or on grounded objects interconnected with the system neutral. Recloser classifying features. Major classifying features in automatic circuit reclosers are single-phase or three-phase. Both single-phase and three-phase reclosers are available to satisfy application requirements. Single-phase reclosers are used to protect single-phase lines, such as branches or taps of a three-phase feeder. Three-phase reclosers are used where lockout of all three phases is required for any permanent fault. They are also used to prevent single phasing of three-phase loads, such as large three-phase motors. Control intelligence. The intelligence that enables a recloser to sense overcurrents, select timing operation, time the tripping and reclosing functions, and finally lockout is provided by its control. There are two basic types of control schemes used: integral hydraulic control or electronic control located in a separate cabinet. A recloser employs one of these controls. Hydraulic recloser control is used in all single-phase reclosers and in smaller ratings of three-phase reclosers. It is built as an integral part of the recloser. With this type of control, an overcurrent is sensed by a trip coil connected in series with the line. When the overcurrent flows through the coil, a plunger is drawn into the coil to trip open the recloser contacts. Timing and sequencing are accomplished by pumping oil through separate hydraulic chambers or ducts. Electronic recloser control is used with larger three-phase reclosers. Compared to the hydraulic control, it is more flexible, more easily adjusted, and more accurate. The electronic control conveniently permits changing timing, trip current levels, and sequences of recloser operations without de-energizing or untanking the recloser. Tripping. Series coil and non-series coil tripping are characteristics of individual classifications of reclosers. Series coil tripping is used on all single-phase reclosers and some three-phase reclosers. Sensing of fault current is provided by a series-connected solenoid coil that carries its rated line current. When a fault occurs, tripping is initiated by a solenoid plunger. The plunger, normally held at rest by the closing springs, is pulled into the coil and causes over-toggling of trip springs in the operating mechanism that opens the recloser contacts. Tripping simultaneously charges closing springs that then close or reclose the recloser when the proper closing signal is present, thus making the recloser ready for another tripping operation. Non-series coil tripping is used only on some three-phase reclosers. It may consist of a tripping solenoid energized from an external power supply that over-toggles tripping springs. It may also consist of a tripping spring simply released by a small tripping solenoid, also externally energized. Closing. Various methods of closing and reclosing are available, depending on the recloser selected. Spring closing is utilized on most single-phase reclosers and some three-phase reclosers. In each case, the closing spring is charged during a previous tripping operation. Solenoid closing is utilized on some single-phase reclosers and some three-phase reclosers. The solenoid coil may be high-voltage AC or it may be low-voltage DC. Motor closing is utilized on some three-phase reclosers. The motor charges closing springs and forces their over-toggle to close the recloser. The closing spring action simultaneously charges the tripping springs. The motor is energized from an external power supply. Interrupter types. Reclosers utilize either oil or vacuum as the interrupting mediums. Oil interruption is utilized on most single-phase reclosers and some three-phase reclosers. Reclosers utilizing oil for current interruption use the same oil for basic insulation. Most reclosers with hydraulic control also use the same oil for timing and counting functions. Vacuum interruption is used on a few single-phase reclosers and some three-phase reclosers. It has the advantages of lower maintenance frequency and minimum external force reaction during interruption. Ratings. Automatic circuit reclosers are rated in terms of various voltages: frequency, continuous current, minimum tripping current, interrupting current, and making current. Warning: in operating a recloser, the limitations imposed by a given recloser rating must not be exceeded in any respect. Otherwise, excessive maintenance or unsatisfactory operation may be experienced. Definitions. Voltage rating. Nominal voltage specifies the nominal system voltage to which the recloser is intended to be applied. Rated maximum voltage indicates the highest voltage at which the recloser is designed to operate. Rated impulse withstand voltage of reclosers is a performance characteristic specified in ANSI C 37.60 as a test requirement. This test demonstrates the ability of the recloser to withstand lightning and other fast impulse voltages. Rated frequency. The rated frequency of reclosers is 60 Hz. The manufacturer should be consulted if operation at other frequencies is being considered. Rated continuous current. The rated continuous current is the magnitude of current in RMS amperes that the recloser is designed to carry continuously. Rated minimum tripping current. The rated minimum tripping current is the minimum current at which the magnetically operated series coil recloser will perform a tripping operation. Standard tripping pickup is 200% of the continuous current rating of the recloser coil. The minimum tripping current for shunt trip reclosers, electronically controlled, is variable and has no relation to the rated continuous current. The differential between minimum trip and continuous current ratings normally provides sufficient margin for load inrush current pickup after an extended outage on a feeder circuit. Rated symmetrical interrupting current. The rated interrupting current is the maximum RMS symmetrical current that a recloser is designed to interrupt under the standard operating duty, circuit voltage, and specified circuit constants. Rated making current. The rated making current is the same value as the rated interrupting current, including the corresponding asymmetry. The recloser must be capable of closing and latching closed against the rated making current and hold closed until a tripping sequence is initiated. Construction. An automatic circuit recloser consists of 5 major components: tank, bushings, mechanism, interrupter, and controls. Tank. The tank is the part of the recloser that houses the interrupter and tripping and closing mechanisms. The tank is usually made of steel, and the top is usually an aluminum casting that supports the various components. Bushings. The bushings are the insulating structures with provision for mounting on the top of the recloser. Operating mechanism. The operating mechanism of the automatic circuit recloser provides the power to open, close, reclose, lock out,